Hi, everybody. This is Steve Sliver, Executive Director of Michigan's PFAS Action and Response Team, and I'll be the first speaker in a presentation about our investigation around the Arbor Hills Landfill. So next slide, please. And so our presentation today will cover a basic introduction of what MPART is doing across the state. Then we'll talk a little bit about the health effects of PFAS and then some site-specific discussion on what we know is occurring around the Arbor Hills landfill. Next slide. Next slide, please. So for some basic background on PFAS, this is a class of over 5,000 man-made compounds that all share one thing in common. They have a really strong carbon-fluorine bond that gives them their unique characteristics of being very stable and heat resistant. They're surfactants and they repel water, oil, fat, and grease. Many of these have been around for over 70 years. Now, of the thousands of compounds that are potentially out there in the market today, we focus on only a few of them. And this is a good point to actually mention that the acronym PFAS for per and polyfluoroalkyl substances pertains to the whole class. And of these, not all behave exactly the same. And so just be aware when we talk about PFAS that we're talking about a class of over 5,000. We look for about 18 of them in drinking water supplies, and actually have health information on fewer of those. Next slide. So it's easier to talk about where PFAS are not used than where they are. They're in Scotchgard, they're in the Gore-Tex water repellent clothing, they're in that Teflon coating on our pans, they're used in metal plating industry, they're used in the firefighting foams, and they're also in many personal care products. They're very pervasive throughout society. Next slide. And so we're concerned about PFAS because they are so widespread. And again, given that strong carbon-fluorine bond, they don't break down easily. They're hard to get rid of. And some of these PFAS, not necessarily all, but some are known to build up in our bodies. And as Lisa will talk about in a moment, there's concern about adverse health effects of some of these compounds. And additionally, as contaminants of emerging concern, we don't have all the information we'd like to have, and especially don't have a real strong regulatory framework for them. Next slide. This diagram really demonstrates how PFAS are cycling throughout our ecosystem because we're not sequestering them or actually destroying them. And the landfill is a really good example because all of the materials that at the end of life end up in a landfill, and industrial waste go there as well, and the PFAS end up in the leachate from that landfill. That leachate typically is passed through onto a wastewater treatment plant, which doesn't effectively treat for PFAS. So the PFAS can end up in our surface waters, which might be sources of drinking water, and also could impact fish where they could bioaccumulate. And the wastewater treatment plants also generate sludges from those treatment operations. Some of those sludges are land applied for agricultural purposes and could impact our soil, groundwater, and surface water runoff, and maybe even crops. And so our challenge is to break that cycle so that we can protect public health. So recognizing the magnitude of potential environmental impacts and public health implications of PFAS, Michigan established its PFAS Action Response Team, or MPART. And MPART is comprised of 7 state departments responsible for environmental and natural resources protection, public health, agriculture, military and veterans affairs, fire departments, and our commercial airports. And MPART leads the coordination of all state efforts on PFAS. And it's really the reason that Michigan has been so successful in rapidly identifying and reducing exposures to PFAS contamination throughout the state. slide. One of the things that MPART is charged with being is transparent. And when we are engaging communities and working with the state, throughout the state, to make sure that folks understand what the work of MPART is and what the implications of PFAS are in their community, one of the things that we're doing is reaching out to a citizens advisory work group comprised of representatives from impacted communities to help advise us on how best to get the message out to communities and make sure that statewide Michiganders are educated on PFAS. And anybody in an impacted community that's interested in participating in this advisory work group can go to the web and the web address that we'll share later and simply register, and we will then contact you to make sure that you are involved. Next slide. So one of the first steps that Michigan has undertaken is to identify sites of contamination where groundwater contamination exceeds state criteria of 70 parts per trillion for PFOA and PFOS. That's just based upon the EPA Lifetime Health Advisory, and it's an enforceable cleanup standard for Michigan. We've prioritized our investigations based upon locations where we know or suspect PFAS have been used, and importantly, where if contamination does exist, it could migrate off-site and impact private residential wells, for example. We have identified 87 locations so far, and these include landfills, airports, military installations, industrial sites, and we are looking for contamination at hundreds more. When we find contamination, one of the first things that we do is we engage all of the MPART agencies, local health departments, and municipal officials to set up town hall meetings like this one to educate and inform residents on what we know and don't know, and engage as well in investigating the contamination off-site, especially those private wells that could be impacted. Next slide. We have integrated PFAS testing into the surface water testing of persistent contaminants in all of our lakes and streams throughout the state to identify and address any discharges of PFAS contamination into our surface waters. We've also found high concentrations of PFAS in foam that might be generated on these impacted water bodies. And we have asked our wastewater treatment plants to look upstream to their industrial users to identify any that might have PFAS in their discharges so that we can address them at the source before they are discharged into the sewer and make it to that wastewater treatment plant where they could then pass through into our surface waters untreated. Next slide. And Michigan has also investigated our drinking water supplies to understand better what the occurrence of PFAS are in drinking water throughout the state. And that began with a survey of all of our public water supplies serving over 75% of Michigan residents back in 2018. We've also expanded that testing back in 2019 and in what we consider phase 2 of that testing, again, to understand what concentrations of PFAS there might be in any of these water supplies serving populations throughout the state. And we conducted as well in 2019 some additional monitoring of supplies where we found some concentrations that required follow-up. We're currently in 2020 evaluating next steps to continue doing some surveys of these public water supplies and going back again to address some of those where we might have found some contamination. Next slide, please. And this slide here shows what we have found during phase 1 and phase 2, and really some similarities in the results that we found. And the good news is about 90% of the supplies that we've tested did not have reportable concentrations of any of the PFAS compounds that we evaluated. Another 7% had very low concentrations of all of the PFAS compounds, and we tested for 14 at that time, and less than 10 parts per trillion were found in 7% of those supplies. And those supplies at that 10 parts per trillion level or less do have recommendations to continue monitoring, at least on an annual basis, but no other action would be recommended at this time. Another 3%, however, were found to have concentrations higher than that 10 part per trillion threshold, but less than a 70 part per trillion action level based upon that EPA lifetime health advisory. Those locations at a minimum have had quarterly monitoring conducted by the state since that time, as well as we've been looking for potential sources of contamination in the area, making sure the consumers of those supplies are aware, and looking at whatever long-term solutions might be necessary should those waters need to be treated. And both in 2018 and 2019, we found a very small percentage in just 3 supplies total where we had concentrations exceeding that 70 part per trillion threshold that required an immediate response and to make sure that people were not drinking water that contained concentrations of PFOA or PFOS exceeding that 70 part per trillion threshold. Next slide. Back in March of 2019, Governor Whitmer recognized that we had done all of the testing of our public water supplies, and as well recognized that across the country and even from our own scientists, the recommendations of 70 parts per trillion of PFOS and PFOA is probably not a low enough level to address potential health impacts of these compounds, and also that other PFAS compounds should be addressed as well in drinking water. So she charged MPART with establishing a science advisory work group to make recommendations to Michigan for developing our own state-specific drinking water standards. Typically, drinking water standards are initiated at the federal level by the U.S. EPA, and then the states adopt those. But at this time, the U.S. EPA has not moved forward as quickly as Michigan would like, so we are proceeding to develop our own standards. And the actual standards are in draft rules that are making their way through the process today. And next slide. And this is just to show the standards that, proposed standards that came out of our science advisory work group. These are health-based values that look specifically at what potential health impacts there might be from all of the 14 and actually now 18 compounds that could be evaluated in drinking water supplies under the U.S. EPA method. And of those 18, our science advisory work group said that there's enough defensible studies out there in the peer-reviewed science today to support drinking water standards for 7 of those compounds. And a couple of takeaways from this chart is that the levels range from 6 parts per trillion to 400,000 parts per trillion. For PFOA and PFOS, the 8 and 16 parts per trillion respectively. How those relate to the EPA's lifetime health advisory of 70, they are much lower. As well as you can see that the numbers vary from one compound to the next, so that these compounds don't all behave the same and have the same impacts on people. And next slide, please. And also need to mention at this point is MPART is not only engaged in identifying the occurrence of PFAS throughout our ecosystem, we're also trying to prevent the creation of new sites. And one of the ways that we can do that is to address the use of the Class B firefighting foams. And so there's a couple of things that we're doing. Back in 2018, we surveyed all of the fire departments across the state to find out who had this material and didn't need it. And so that has led to actually a collection program underway in the state right now, where we are collecting up to 34,000 gallons so it can be properly disposed from, again, those agencies that don't need to keep this in inventory. For those that do need to keep it, we've also given them some recommendations for practicing and not practicing with the foam itself, but using other best practices to make sure that their equipment is good to go for use with fighting fires, as well as notifying the Department of Environment, Great Lakes and Energy if they do happen to use it, so we can make sure that it's been cleaned up afterwards. As well as we are working with our state and federal partners to identify alternatives to the Class B AFFF so that we would not have these fluoride in the future. All right, so I'm going to hand it off now to our next speaker, Lisa Fisher from the Department of Health and Human Services.
Hi, my name is Lisa Fisher. I'm a toxicologist with the Michigan Department of Health and Human Services. Today I'm going to talk about how MDHHS assists the local public health departments with PFAS investigations, and I'm also going to cover the MDHHS Comparison Values for PFAS and the results of the residential well sampling that was done near the Arbor Hills Landfill. Next slide. So the role of MDHHS is to provide support to the local health departments involved in this investigation. This included both the Washtenaw County Health Department and the Wayne County Health Department, since the landfill is kind of split between the two counties. We can provide specialized expertise on PFAS, and in return, the local health departments provide us with information about their local community that is useful to our investigation, like how many residential wells are in the area and how likely those wells are to be impacted by contamination. We're also on hand to help the local health departments answer questions that they receive from their community. And while EGLE focuses on the site investigation as a whole, MDHHS and the local health departments focus on making sure that human health is protected, which means sampling residential wells when necessary. I also work with the local health departments to develop a public health action plan before sampling even begins. This way, once results come back from residential well sampling, we can respond immediately to provide bottled water or filters if needed. Next slide. So there's a lot of different ways that we can be exposed to PFAS. Like Steve said before, it's in a lot of consumer and household products. So it's very hard to avoid exposure to PFAS. One of the major routes of exposure is through drinking water. And like was shown on that diagram earlier, some of these products can get into groundwater, which can get into drinking water wells. Another route of exposure is from eating fish that come from a contaminated water body. We do have some fish consumption advisories across the state due to PFAS. One of those is a do not eat advisory on the Huron River from Wixom down to the mouth of the river. Another route of exposure is from accidentally swallowing contaminated soil or dust. This could occur, for example, if you're gardening in contaminated soil and you eat something without washing your hands first. In general, this route of exposure is more of a concern for small children because they're more likely to eat large quantities of soil or dirt accidentally. And like was also mentioned earlier, food packaging can sometimes contain PFAS, which can transfer to food and lead to ingestion of some PFAS through that route as well. In general, PFAS does not easily absorb through the skin. Sometimes PFAS-containing foam can be present on water bodies, and we recommend that you avoid contact with the foam as a precaution. Next slide. So now that we've discussed all the ways that we can be exposed to PFAS, it shouldn't come as a surprise that all of us have some PFAS in our bodies, which can be detected in blood. This chart shows the average levels of some PFAS in Americans from 2000 to 2014. If you notice that top green line for PFOS, it drops dramatically between the years 2000 and 2004. And that's most likely because some companies stopped manufacturing PFOS in 2002. So as you can see, those PFOS levels in blood have continued to decrease. Next slide. So the reason why we're concerned about PFAS is because there are some health effects associated with exposure. This is a list of health effects that are associated with either PFOS and or PFOA exposure, and they include lowering a woman's chance of getting pregnant, increasing the chance of high blood pressure in pregnant women, for PFOA exposure, increasing the chance of thyroid disease, increasing cholesterol levels, changes in immune response, and an increased chance of cancer, especially kidney and testicular cancers. Next slide. So PFAS-related health problems are associated with what we call chronic exposure. So these are effects that aren't going to show up after a couple days or couple weeks. This means that being exposed to an elevated source of PFAS for years or decades makes you more likely to develop health problems later on. But all humans are different. Just because you were exposed to a high-strength source of PFAS for years doesn't necessarily mean that you will develop these health problems. It simply means you're more likely to develop health problems compared to someone who wasn't exposed. Next slide. So I'm going to talk a little bit about the sampling of the residential wells that was done in the area near Arbor Hills Landfill. And when we get these results back for the wells, well water, we like to consider multiple lines of consideration. So we sampled some residential wells that were down gradient of the landfill just to make sure that they weren't being impacted by PFAS. We look at Eagle's Part 201 drinking water cleanup criteria. That's that 70 parts per trillion PFOA plus PFOS. And if any household is over that criteria, we provide them with bottled water until a filter can be installed. We also look at the MDHHS Comparison Values, which I'll talk about in a couple of minutes, and we provide filters to those households that exceed any comparison values. We also look at the residential well results collectively, individually, to determine if any other households in the area need a filter. So, for example, if a house has low levels of PFAS but is surrounded by houses that have high levels, we may provide that low-level house with a filter as a precaution. We also take into account site-specific information. That includes estimating the down gradient flow of the known or suspected source. Well depth and geology are also important to take into consideration, since deeper wells may be less affected by PFAS contamination than shallow wells. Also, having a clay layer is an important barrier to stop PFAS from reaching groundwater. So this is all the information that we take into consideration for determining if public health response actions like providing a filter or bottled water need to be taken. Next slide. So what are the MDHHS comparison values? We look at both the MDHHS public health drinking water screening levels and the MPART health-based values. And both the MDHHS screening values or screening levels and the health-based values were set to protect everyone. That includes sensitive population groups, which is often fetuses and infants. And because they're protective of the most sensitive population, that means they're also protective for everyone else. Next slide. So this goes over the PFAS results of the residential wells that we tested. We sampled 7 wells in the area that were down gradient of the Arbor Hills landfill. Of those 7 wells, only one of them had any PFAS detections. That was a low-level detection of PFHXA. This detection did not exceed any of the MDHHS comparison values and did not exceed the Part 201 drinking water cleanup criteria. Next slide. So based on these well water results and what is known about the area, we determined that no public health actions are necessary at this time. So residents whose homes were sampled will be receiving a letter from MDHHS that says what their results were, and it'll provide some information about PFAS in drinking water. Many of the homes in this area have deep wells and a confining clay layer. which may be protecting their drinking water from PFAS contamination. And I'm going to hand it over to Brett, who's going to go into the Eagle investigation in the area.
Hi, this is Brett Coulter. I'm a district geologist with the Materials Management Division in the Dick Jackson District Office. Next slide, please. So I'm going to discuss PFAS sampling at Arbor Hills, specific actions. The PFAS sampling was triggered through the MPART initiative, as described earlier. This MPART initiative includes the sampling of several wells at Arbor Hills Landfill for PFAS. These wells are placed around the landfill and the water is periodically sampled to evaluate water quality. We'll also discuss groundwater and groundwater flow at the landfill and in the area, potential PFAS sources of the one detection on the landfill, actions taken by Arbor Hills to investigate this detection, residential water sampling as discussed earlier, and then a summary of these activities. Next slide, please. Let's start with this aerial photo showing Arbor Hills landfill and surrounding areas. The blue arrows indicate the expected direction of local groundwater movement, which is to the southeast. The red circle shows the location of a PFAS detection on the landfill in the southeast corner of the property. As previously discussed, the Part 201 drinking water criteria for PFOA plus PFOS is 70 parts per trillion. The results of the water collected at the location shown exceeded this criteria and triggered additional activities. Next slide, please. So before we get into the additional activities, let's discuss some of the potential PFAS sources related to the PFAS detection in the southeast corner of the landfill. These include groundwater, leachate seeps from the landfill, and a former recycling center fire in which PFAS containing foam was used to extinguish the fire. Some additional information on the PFAS detection on the landfill includes the depth of the water sample collected was about 30 feet below grade. And it's important to note that most residential wells are set greater than 80 feet below grade. And that typically one or more clay or silty layers, as Lisa pointed out, separate this upper zone and the residential water wells and the depth from where the landfill sample was collected. These clay and silty layers impede the downward flow of water. 2 samples were collected from this location and both showed similar results. Next slide, please. So the detection on the landfill triggered the preparation of additional investigation. This additional investigation included the preparation of a work plan to further address the PFAS detection on the landfill. The general objectives of the work plan are to evaluate potential pathways, and potential pathways are possible routes of travel for the PFAS, determine the extent of PFAS horizontally and vertically, both in soil and groundwater, determine a source of the PFAS, and evaluate risks, potential risks to human health and the environment. If any possible risks are identified, additional actions such as expanding the monitoring network or evaluating cleanup options for PFAS will be taken. Next slide, please. In addition to the Arbor Hills investigation, MPART, along with MDHHS and local health departments, as well as local officials, it was determined that we would sample residential wells. As Lisa mentioned, we sampled water from 7 residential wells for PFAS. And all the residential water samples show the water is below Part 201 standards for drinking water for PFAS. Next slide, please. A summary of the activities taken at Arbor Hills Landfill and around Arbor Hills Landfill. We had PFAS sampling, and that was initiated through the MPART process. The result exceeding Part 201 drinking water criteria on the landfill led to the preparation of a work plan to further investigate PFAS. In addition to the ongoing Arbor Hills PFAS investigation, MPART collected water samples from 7 residents, and all 7 water sample results were below the PFAS Part 201 drinking water criteria. If you have further questions on the information presented in this webinar, these slides show contact information and provide a link to the MPART website where this information and future site updates will be posted for Arbor Hills Landfill.